next, I like to invite our colleague, Vincent Falardeau. He's an application specialist here with us. And Vincent is going to be sharing with us some tricks. So I'm going to give Vincent the screen so he can take it away. Hello, Vincent. Are you with us? There you are.
Yeah.
Excellent. Welcome. And thanks for joining us.
Yeah, thanks for having me. I'm
Awesome.
going to share my screen here. All right, are you able to see the screen? Or?
Yeah, we can see it. Take it away. Thank you.
So I'm going to, we're actually going to stay in Canada. I'm going to be sharing a tip for using Global Mapper Standards, raster calculator and raster reclassification tools to map wildfire severity in Quebec. So we're going to start by connecting to some online data. As was mentioned in that last question and answer session, Global Mapper has a lot of built-in online sources that you can use for analyses. Here we're going to use Sentinel-2 satellite imagery by clicking on the Copernicus Open Access Hub and then clicking Connect in the top right. We'll be launched into a browser where we can find online data to use for our project. You have to have a free login to connect to the products on the Copernicus browser. I've already downloaded some data, but if you get a copy of my presentation later, you can download your own data via the link or go back to those online sources in Global Mapper. Now you can enter a time range and choose the product or the satellite type that you want to use for your download. Here I've entered July 2023 and I've entered the L2A atmospherically corrected products, zooming in on central Quebec province to look at those areas that were affected by a lot of wildfires last summer. Click download and it should download onto your device. You'll have to extract a zip. That's the way that the Sentinel data comes through, and burrow into the granule folder to find the band 8 near infrared image in that 10-meter folder and the band 12 shortwave infrared image in the 20-meter folder. Those are the two critical bands from Sentinel data, which will be used in calculating a normalized burn ratio, which we can use to assess wildfire. Load in those images via file open data files in Global Mapper or by dragging them right into the control center. And your workspace should look something like this. On the bottom, we've got the band 8 image, and on the top, currently shown in the workspace here, is the band 12 shortwave infrared image. Now, where it gets interesting, we go to raster analysis, raster calculator, and we apply a formula to the image layers. In the dialog box for the formula options, we're going to add a predefined formula. So the raster calculator is actually a really powerful tool for conducting analyses of imagery data that you can download from the online sources. In this dropdown, you can find the NBRI, the normalized burn ratio index, specifically for the Sentinel-2 MSI, in this list of predefined formulas. So you'll click Add Band, and what it shows is this formula. Essentially, it's just a normalized ratio of B8 and B12. Click to create a multi-band image with 32-bit depth, and hit OK. You'll be prompted to select the appropriate bands, do so, and then hit OK. It might take a second. And the completed process results in a normalized burn ratio image for July 2023. So here we can see in these darker areas, those are areas of lower normalized burn ratio, and those brighter areas are a higher normalized burn ratio. But what that actually means is that the higher value areas are better vegetated. The lower value areas are going to be the ones we'll find that have been burned in that period leading up to July 2023. So what we have to do is compare pre-fire and post-fire normalized burn ratio. So I repeated all of the steps 1 to 11 in those previous slides for May 2023 Sentinel-2 L2A imagery in the same location. And when you load that in, you get a normalized burn ratio image where virtually none of this area has been affected by fire yet. You can see that it's all roughly the same values, the same shade of gray, the same normalized burn ratio. But when we compare pre-fire and post-fire, we're going to see a much clearer story. So in the raster calculator, you'll calculate the delta NBR, or the change in NBR, by creating a custom formula, B1 minus B2, and then you'll set May as the B1 and July as the B2 image. Again, it's a 32-bit multi-band image output. Now in the raw delta NBR image output, the higher values now indicate greater burn severity. And it's a very stark picture between these bright white areas in the raster image and these darker, nearly black areas. You can see very clearly and crisply where the change in NBR was especially high. The values that come out of a pre-fire versus post-fire comparison are just a raw value on a scale of -1 to 1. So to get an idea of what those values actually mean, we're going to reclassify based on severity levels that were proposed by the USGS. And we can see here that these lower values might indicate regrowth. Medium values might be unburned or low severity fire. And then as you get to the higher values, it's moderate to low, moderate to high, or high severity of fire. So to do this, we're going to go to raster analysis, raster reclassification. And alongside the raster calculator, reclassification is another really powerful tool for isolating the values that are really important in your imagery. We'll enter the ranges as above to replace the raw index of delta NBR with a palette image where each color represents a severity level. On the next slide, we'll reclassify using a rule set that I made by entering those USGS values. So you can either enter the values manually into this table here, or you could click load and you'd be able to load a rule set, which is essentially just a saved table of these row values, input values, output index, a description, and a choice of the color palette. So it's all loaded up just fine like that. You'll hit OK. You could also validate to make sure that your reclass rules conform to the standards of the reclassification tool. And what you get is a final image that shows where the fires most severely burned in central Quebec between the images I took from the online source, May 28th and July 28th. So in that 2-month period, you can see this stark change in these areas that were moderate to low or moderate to high severity burns, which, as we know, created these large scale smoke plume effects over the northeastern United States and Canada and into the Midwest. It was a big wildfire season for Quebec last year. And loading in some world imagery underneath and isolating just those moderate to high severity burn areas, you can really see where the landscape was severely impacted by fire on a scale of, 25 to 50 kilometer scale fires. That's all I've got for you today. I hope that you learned something from this Global Mapper Standard tip and trick.
Thank you so much, Vincent.